So we're going to have fun with large spheres, in this case, the Earth and the Sun. And we played around with, I think, the Earth and the Sun before when we were looking at the gravitational pull between them. This time we're going to compare the sizes of the Earth and the Sun. And so information that we need to play around with here are the radius of the Earth and the Sun, so the distance from the center to the edge, and then how much stuff is inside the Earth in terms of, well, not how much stuff is inside, but how much space the Earth and the Sun take up is more like it. So I'm going to make a table to keep track of some stuff, then we'll worry about the formula things here. So let's see, which order do I want my table in? How about this way? We're going to put the Earth here, and the Sun here, and then information that's important is going to be the radius of each and the volume of each. And then, because the numbers are so big, we're going to write some of them in scientific notation also. So let's see. I'm going to skip on down past this first stuff. We'll come back to that in a minute. The Sun has a radius of about 695,000 kilometers. And we're asked to find the volume and put it in scientific notation. So just for fun here, I'm just going to write that number first. Make a note here, radius is kilometers, and that the Sun is 695,000. In scientific notation, that would be 6.95 times 10 to the power 1, 2, 3, 4, 5. To get the volume of the Sun, which I'm asked for here, I've got to use the formula given up there. So we're going to take 4/3 times pi, and then times the cube of this radius here. So at this point, it's pretty much calculator time. And I'm going to make a note down here of what I'm doing. V equals 4/3 times pi times the radius, parentheses, which is 695,123. Now that's kilometers, and I'm cubing it. So whatever answer I get is going to be kilometers cubed or cubic kilometers.
Okay, that helps a lot.
Yeah, so if I just kind of sneak that in here, if I put the kilometers in there, which goes with this measurement, I am cubing the measurement as well as the number. And so we're going to get kilometers cubed as the answer.
Right, because see, you know, on that first one you're doing, it's out to the side, but like if I'm taking a test, I need to write that out.
Yeah, on a test, like on the share your work, I want you to write something down on paper. And so, yeah, that's what we would write down. And I'll write my stuff down in a sec. So first I need my calculator. I think I'll just use the Google calculator. So 4/3 is just 4 divided by 3, whether it's stacked or not, doesn't matter. Times, use your pi button instead of 3.14. And then I want to take my 695,123 and raise it to the 3rd power.
You taught me this, Gary. I put like V equals 4/3 times pi, and then I put the 695,000 in parentheses raised to the 3rd power.
Yes, yeah, and on the calculator, the parentheses are good too. And sometimes I will skip the parentheses if I don't think I need them. So in this case, you should get the same answer either way.
Okay.
We talked about this the other day. This E on the calculator, sometimes it's a big E, means scientific notation. And back in the original problem, they said since we have 3 places here, we're going to use 3 places. So that's an idea called significant figures or significant digits. So I only need the first 3 digits here. So I would say, oops, 3 digits. 1.406 times 10 to the 18th is what I'm getting.
Kilometers cubed.
Correct.
Okay, that's what I got.
What was that? 10 to the 18th.
Hello?
All right. So we got that number, and it's automatically in scientific notation because it was a big number on the calculator. So I'm going to put that in my table too, 1.406, 10 to the 18th. Now the Earth, we're given the volume, so we need to reverse engineer that. And so we're asked, which is the right formula? So let's back up and calculate that. So we need to solve for R, the formula V equals 4/3 pi r cubed. And we did something like this earlier when we were playing in the lesson. So here we're going to do a similar thing. In the lesson, I did it two different ways. Here I'm going to do it the first way I mentioned, which is to get rid of the 4/3 by multiplying by 3/4. And again, 3 divided by 3 is 1, right? 4 divided by 4 is 1. 1 times 1, that doesn't do much. It's just 1 times whatever. So at this point now, I have 3/4 V equals pi r cubed. So next thing I would do is divide by pi. And this looks messier than it is, so we'll look at cleaning this up. The right side's pretty straightforward. A number divided by itself is 1. So as far as the 3/4, there we go, times V, I can view that as V over 1. And so I can call that 3V over 4. Then we took that 3V over 4 and we divided it by pi. Dividing with fractions is multiplying by the reciprocal. So I can say this is 3V over 4 times 1 over pi, which just gives me 3V over 4 pi. And that right there is what the r cubed is equal to. And we learned the other day that we can get rid of a cube with a cube root.
I'm sorry, that was my doctor confirming my appointment for tomorrow. Are we doing the volume of the Earth?
Yes, we are.
Okay, thank you.
Yeah. So cleaning this up right here, the cube root and the cube cancel. So I get R is the cube root of that whole big fraction. So that whole big fraction is inside the root. And I would just leave it that way. And one of those formulas we were given should match that. And this one had a 4/3, so we want a 3/4. So that on my version, it's the second one matches that one. So that's the formula I use. And so we're given the volume of the Earth. So if we plug that number into our formula, we should get the radius back. So 1.1 times 10 to the 12th. So the volume of the Earth is 1.1 roughly times 10 to the 12th. Oops, extra 1 there. And that is kilometers cubed. Check units. Yep. And we're going to plug that into this here. And notice when we do that, like if we take the cube root of this, we're taking the cube root of kilometers cubed, and the cube and the root are going to cancel. So just a side note, if we take the cube root of kilometers cubed, the cube and the root cancel, leaving just kilometers behind, which is good because we're trying to find the radius, which should be in kilometers.
So the final answer will be kilometers, correct?
Right, that's what I'm justifying here.
Okay.
Yeah. So I'm not going to plug the kilometers cubed into the formula. I'm just going to plug the number in. So then the radius of the Earth is going to be the cube root of 3 times 1.1 times 10 to the 12th divided by 4 pi. And on my Google calculator, I'm going to need to put this in parentheses because Google calculator doesn't stack these. If your calculator stacks these, you don't need the parentheses. So it depends on your calculator. So let's see if we match answers. And now if you need to go before we're done, I am recording this.
Okay, thank you. I just realized the time when you said
Yeah,
that.
right. So I don't want to keep you. All right. Oh, another note on my Google calculator is I don't have a cube root button. So on my Google calculator, I'll have to take all of that to the power 1/3. So you try it on your calculator, see if we get the same answer. Hopefully.
I did it on Desmos and it worked great.
Yeah, Desmos is a nice calculator. I just like to demonstrate different ones. So I'm going to go parentheses, and then I have 3 times my radius, 1.1 times 10 raised to the 12th. And then I want to divide that, and here I have to use another set of parentheses for the denominator, 4 times pi. And then that's my denominator, and then I need to finish the parentheses for the whole fraction, and then take the cube root by raising it to the power 1/3. If your calculator stacks stuff, it's not quite as complicated, but you may need, yeah, the Desmos calculator is a little easier to use here. So if I type that right, I get a volume, or sorry, a radius of 6,404. I'll see how many decimal places they want. Anyone else get that answer? 6,400-ish?
Yep.
Okay. How's it going, Joe?
Yeah, I did not get this one right.
Okay. Did you just try to recalculate it?
No, I was just kind of following what you were going through.
Okay. Yeah, so one thing you do is you want to, often it's a calculator problem that happens here. So I'm going to demonstrate on Desmos just for fun. Is your calculator more like Desmos, or is it more like the Google one?
No, I've been using Desmos.
You've been using Desmos. Okay. Oops.
Yeah, that is so much better, Gary.
Yeah, and I have the Desmos calculator on my phone. I have an iPhone, and the iPhone calculator sucks.
Yeah.
You do a lot of things well, but that is where you gotta fix that someday. I write to them every year about it. Say, hey guys, come on, let's fix this.
That's what I did. I put 3 there, and
So
then I
cube
put,
root, and then I have a fraction. So that's either the fraction button or the division button. And then in the top here, I have 3 times. To be safe, I could use parentheses, 1.1 times 10 raised to the 12th, and then close the parentheses. And the bottom should just be 4 pi.
times pi, yeah, 4
And I
pi.
get the same answer that my Google calculator said.
Good, I did it right.
And a lot of times I'll use 2 different calculators just to make sure I'm doing stuff right, because oftentimes I make mistakes on a calculator too. To the nearest 1/10 of a kilometer. Okay, so to the nearest 1/10, it would be 8/10 of a kilometer. So 6,403.8. So I want that in my notebook, not really there right now. So then this is approximately 6,403.8. Double check. Calculator. Yep. All right. And earlier, I justified that if I take the cube root of kilometers cubed, I should get kilometers because the root and the power cancel. And that's why we learned about roots. And so this is definitely kilometers. All right, so that is the radius of the Earth. Name, so it's capitalized. So let's add that back here to my table. So we were given the volume of the Earth. That was 1.1 times 10 to the 12th. And now I have the radius, which is 6,403.8. Radius is in kilometers, volume is in kilometers cubed on both of those. And then I'm asked to compare the Earth to the Sun. And whenever we're comparing to see how many times bigger or smaller something is, we just divide. So in this case, I just want to know, hey, for the radius, what's the Sun divided by Earth? Okay. And that will give me the answer. And let's see. So now we can do times bigger. I should say Sun is blank times bigger than Earth.
And there's no kilometers or anything after that, right?
Yeah, because what happens is we're taking kilometers and dividing by kilometers, so we're just getting a multiplication factor, and it has no units.
It's just like saying like 10 times or
Yeah.
whatever.
Yeah, like I'm 50, my friend is 10, I'm 5 times older than my friend.
Okay.
Right?
Would I have got it wrong? I went 695,000 divided by 6403.755, and I got 108.53 times the Earth's radius.
Okay, let me catch up to you there.
Okay.
So what I'm going to type into my calculator in a second is, I don't really need the scientific notation for the radius because they're not too big. I want to take the sun, 695,123, and divide by the Earth, 6403.8. And that'll tell me how much bigger the top number is than the bottom number, right? I'm trying to figure out how many times the Earth goes into the sun in terms of the radius. So calculator time. And I'm getting it's almost 11 times bigger if I type my numbers right. And I didn't. I missed a decimal point. There we go. 100 times. Okay.
I was going to say I got 108.53.
Yeah, so it's about 108 times bigger. So now let's look and see what the computer, how it wanted us to answer. Use at least one decimal place. Okay. So then I should be able to say that this is about, I'm just going to use one decimal place, 108.6, is that right? Or 5? 108.5.
So I need to quit going out so far then.
Oh, you should be able to go out 5. It said at least, so it should take multiple answers. So just to check that.
I did get it right. I put 108.53.
Yeah, that should work too. Yeah. And again, just read the fine print on how it wants the answer entered. All right. And then similar thing, we want to do that for the volume comparison. So just a picture of what we're comparing here is, let's say here's the Earth right here. Let's make the Earth blue. And let's say here's the sun over here. And these are not to scale. Important note, not to scale. I can't actually draw the two of them to scale on this screen, I don't think. The Earth radius is that distance right there, and we're claiming that distance is about 6,400-ish. And then the sun's radius is right here, and we claim that one is 695,123, right? And we can see the sun's radius is way bigger. And the ratio we just calculated is that the sun's radius is about 100 times bigger. And I'm just going to rough it at 100. The sun's radius is about 100 times the Earth's radius.
But my 108.53 would not be a wrong answer, correct?
No, that's right too. Yeah, I'm just rough. Yeah, like if I'm explaining this to my mom, she'd rather have I state it's about 100, right? 108 to 100. So just kind of news blurb there in the East Oregonian. Hey, by the way, the sun's bigger. Here's how many times bigger about. So if I drew this to scale and this was the Earth's radius, then I would need more of 100 of those line segments to draw the sun. And I can't fit that on this page. I'd have to make the Earth very, very tiny. Like I'd have to make the Earth about that big. And the sun would be about the size of the whole page for comparison. All right, let's do the volume comparison now. So for the volume comparison, we want to divide these two numbers. So I'm going to pick a new color. And again, it's the wording of the question said the sun is blank times the Earth. So the sun has to come first. So we take the sun's number, 1.406 times 10 to the 18th, and we divide by the Earth's number, 1.1 times 10 to the 12th.
Yeah, I did it right.
On some calculators, you may need parentheses, right? On the Google calculator, I do. On the Desmos calculator, I don't, because Desmos stacks those fractions. So we always got to pay attention to when do we need parentheses. You can always put them in if you're not sure.
That's what I do, because you said they won't hurt on a lot of things.
Yeah, as long as you use them right, they won't hurt. All right, so I'm going to put them in just for fun. So 1.406 times 10 raised to the 18th. And then I'm always going to go back and double check that I type them right, because sometimes my mind or fingers do something other than what I intended.
Yeah, me too.
10 to the 12th. So I think those were my numbers. And like you can see, I
That
missed
10
a
to
button.
the
There we go. All right, and I put parentheses in just to be safe. And now I just want to double check I have the numbers right. 1.406, 10 to the 18th. That is here, yep. And then 1.1 times 10 to the 12th. So I'm pretty sure I typed them correctly. And then it looks like I'm getting about 1 million times. 1, 2, 3, 1, 2, 3. So volume-wise, like the amount of space they take up, the sun takes up over 1 million times more space than the Earth. Whoa. Okay, how were we asked for that answer?
Did you get 1278181.82?
1,278,181.8 if I went to one decimal place.
Oh, okay. So my 0.82 is okay though.
That's okay too, yeah.
Okay.
So I'm gonna pull this to the side. Just so I can write
And
it down
that's another
correctly.
one that's just the time. It's just that much times bigger. I don't have to use
yeah.
kilometers or anything.
No, because here, the top number was kilometers cubed,
Mm-hmm.
and we divided by kilometers cubed,
Right.
and those divide out.
Okay, thank you.
So then I'm going to say 181.8. And that's how many times bigger. And so, like reporting in a news story, I'm going to say, that's about 1 million. Okay, it's closer to 1 million than 2 million. It's closer to, yeah, we'll just call it 1 million about. So in my sentence to like my mom or the media, let's see, in the next page, I should be able to fit this. Yeah. So the sun's volume is about 1 million times the volume of the Earth. The Earth's volume, if I word it the same way. And just something to think about here. When we take a radius, and here we're just comparing the two radii, in the formula v equals 4/3 pi r cubed, right? We're cubing the radius. And just note, what do you get when you cube 100? Because we're cubing that difference when we look at the two of them. That would be 100 times 100 times 100, right?
Right.
Which is 1 million.
So that's why you said it was.
That's why we're getting that ratio of 100 when we look at the radiuses, but 1 million when we look at the volumes, because we're cubing those numbers. The cube of 100 is 1 million. So if the radius is about 100 times bigger, the volume will be about 1 million times bigger.
Is about 1 million times bigger than the Earth.
Mm-hmm, correct. The volumes. Yeah, and
Yes.
so when we're comparing two things, there's lots of ways we can compare two things. We can compare, like in this case, if they're balls, they're spheres, we can compare, well, how are the radiuses different? How are the volumes different? We could also compare the mass of each. And mass is different than volume, because mass takes into consideration the density of it. Like think about a wooden ball versus a lead ball. If they have the same volume, the lead ball is going to be way heavier because lead's more dense than wood. And my belief about the sun is that it's pretty dense near its core, so we'd probably find that it's probably more than 1 million times the mass of the Earth. But that's something we'd have to look up and calculate.
Oh, please don't.
I'm curious. I'm going to look it up after class. And
Okay, because I'm just holding it together by a string.
All right, so we did it. We answered all those questions there. We have answers for each of them.